This lesson is over ratios. So let's look at our how do you know, our number routine. In this number routine, it says, how do you know that 2.5 times 3/4 is equal to 1 7/8? While 2.5 divided by 3/4 equals 3 1/3. Notice how when you multiply here, the product is smaller. While here, you're dividing, it's getting larger. Why is that? So let's look at the first one. 2.5, let's write it as an improper fraction as 5/2. And then you multiply by 3/4. The reason why it is getting smaller is because you started with the number 2.5. You're multiplying by a number that is less than 1. So your product will be less. So if you multiply this, you get 15/8. How many groups of 8s go into 15? 1 whole and 7/8. If you cannot do that in your head, you can divide 15 by 8 and figure out how many 8s go in 15 one time. Remainder 7 or 1 7/8. Alright, next one. So we have 2.5. That's 5/2. So what do you remember about how to divide? Well, we need to multiply by its reciprocal. So we can write an equivalent multiplicative expression. So we keep the 5/2 or 2.5. Then we multiply the reciprocal of 3/4 as 4/3. And you get 26, which you can simplify to 10/3 by dividing both even numbers by 2. And then how many groups of 3 go into 10? 3 whole, and you have a leftover of 1/3. So 3 1/3. The reason why this is getting larger, you're finding how many groups of 3/4 go into 2.5. It's about 3 groups. So grab a handful of rainbow cubes. Blah, 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 blah. Done. Can you make some observation and be ready to share with your tribe and class? I noted there are 5 purples. There are 7 blues. What else can I say about this? There are about 20 cubes in all. If that's what I noted. There are 5 yellow. There are 4, 1, 2, 3, 4. There are 4 orange. There are, compared to the purple, there are 7 blue to 5 purple. I can say most of the colors, from what I can see according to my data right here, there are 7 blue out of 20 cubes. So, did anybody compare part to part or part to whole? If so, you just did ratio. Ratio is comparison of 2 values. So I kind of did it, but I didn't really use the word ratio. So I guess I know what ratio is without even doing it. So I compared the purple to the blue. There are 5 purples to 7 blues. Part to part. Or like I said, there are 7 blues to 5 yellow. Part to part. Or I can do part to whole. There are 4 orange to 20 cubes. Part to whole. So there's 20 orange to 24. There's 4 orange to 20 cubes all. I can simplify that by dividing both numbers by 4, and I get 1/5. So in other words, there are, for every 1 orange piece, there are 5 cubes. So I could take an orange piece, this one right here, and match it up with 4 more pieces. So there's 1 orange for every 5 pieces. This 1 orange match up with 4 other pieces, so it makes 5, and so on and so on. So that's ratio. Ratio compares value. A ratio says how much of one thing there is compared to another thing. There are no units, as you can tell. There are many ways to compare quantities. For example, here you have 3 asterisks to 12 number symbols. So if I ask you to compare the asterisk to the number system, you would say there are 3 asterisks to 12 number symbols. Or you could rewrite it as 3:12 or 3 asterisk colon 12 number symbols. Or you could write it in a fractional form as there are 3 asterisk to 12 number system. So these are the 3 ways you can write a ratio. I personally I mostly write it in the fractional form. And I like this one. I sometimes use this one. But they're all ratios. They're all equivalent. As with fraction, ratios are often expressed in simplest form. Ratios can also be expressed as decimals. So you can simplify. As you can see here, there are 3 to 12, 3, 12, 3, 12. What can I divide both numbers by? I can divide the numerator and denominator by 3. So I get 1 over 4. So I can rewrite it as 1 to 4, 1 colon 4, and 1 4. That's equivalent to 3 to 12, 3 colon 12, and 3 12. And what decimal form is 1 4? 25 hundredths. In case you forgot, 1 divided by 4. Can 4 go in 1? Nope. Put a 0.0. How many 4s go into 10? 2 times. 10 minus 8 is 2. Bring down the 0. How many 4s go into 20? 5 times. So that's why you get the 25 hundredths. Or you can say, can 1/4 go into the hundredths place? 25 times. That means for every 1 asterisk, there are 4 number systems. Is that really true? Let's see if that's true. Let's get my highlighter out and see if that is true. 1 asterisk for every 4 number symbols. 1 asterisk for every 4 number symbols. And last but not least, 1 asterisk for every 4. So I can I'm comparing 2 quantities. Comparing 2 things, I could say there's 3 asterisk to 12 number symbols. That's comparing. Or I can say there's 1 asterisk for every 4 number symbols. That's comparing. So that is part to part. If I wanted to do a part to whole, I could have said there are 3 asterisk for a total of a whole of 12 plus 3 is 15. And that would be the part to whole. So the ratio of dogs to cat is blank to blank. How many dogs do I see here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 dogs. How many cats do you see? How many meows do you see? I see 3. So the ratio of dogs to cat is 9 to 3. Or 9 colon 3. Or 9/3. Could I simplify that? You bet I can. I can divide both numbers by 3. So that leaves me with 3, 1. Before you said, oh, that's just 3. In ratio, we're comparing 2 quantities. So I need you to leave it in with 2 numbers. That means there are, before you said 3, 1. What does that mean? There are 3 dogs for 1 cat. There are 3 dogs for 1 cat, or there are 3 times as many dogs as cat. Is that really true? Let's see if that's true. Here are 3 dogs, 1, 2, 3, 1 cat. Here are 3 dogs to 1 cat. Here are 3 dogs to 1 cat. So I did a part to part. I compared the dog to the cat. So I could have said 9 dogs, 3 cat, or 3 dogs for every 1 cat. In our subsequent lesson, we are going to be learning something called ratio tables, where you can say 3 dogs, 1 cat. You can build it up again. 6 dogs, 2 cats. 9 dogs, 3 cats. 12 dogs, 4 cats, and so on. So what's the ratio of cats to dogs? So we want to do another part to part. Cats. How many cats were there again? 3 cats to 9 dogs, or 3:9, or fractional form 3/9. If I divide both numbers by 3, I get 1/3. But what does that mean? 1 cat, 3 dogs. Look at these pictures. 1 cat, 3 dogs. 1 cat, 3 dogs. 1 cat, 3 dogs. So there are 1 cat, 3 dogs. Or what is the decimal form of this? 0.33. Repeating. Times as many cats as dogs. Again, in case some of you may have forgotten, how do you turn a fraction into a decimal? How do you say this? 1 divided by 3. So we must divide this. 1 divided by 3. Can 3 go on 1? 0 times. How many 3's go into 10? 3 times. 10 minus 9 is 1. I need to get rid of this 1. Add another 0. Bring it down. How many 3's go into this 10? 3 times. That's 9. I need to get rid of this 1. Isn't this deja vu? Didn't we just do this like several times? It must be repeating. Next one. The ratio of girls to boy is blank to blank. So how many girls to boys do you see here? According to this, I see 3 girls to 2 boys, or 3:2, or fractional form 3 halves, or 3 girls for every 2 boys. There are 3 girls for every 2 boys. Or what decimal is that? 3 divided by 2. How many 2's go in 3? 1 time. 3 minus 2 is 1. How do I get rid of this 1? Remember, I don't want to change the value of 3, so I had a 0.0. So bring this down. How many 2's go into 10? 5 times. So it's 1.5. So there are 3 halves, or 1.5 times as many girls as boys. Now let's do a part to total. What is the boys to total? There are 2 boys to a total of 5 individuals. The whole group has 5. 2 boys, 5 people. So it's 2:5. Or in fractional form, 2/5. So let's do a multiplicative comparison. There are 2/5, or what decimal is that? 2 divided by 5. Oh, I'm going to build this to the 10th place, because I can't build this to the 10th place. How do I build this to the 10th place? I multiply both numbers by 2 and get 4/10. So there are 2/5, or 4/10 times as many boys as total. Does order matter with ratio? Explain your reasoning. For example, I said the ratio of girls to boys is 3:2. Look at the picture, 3:2. If I had said the ratio of girls to boys is 2:3, would that have been incorrect? No, it would not have been correct. So order does matter. Because look at the picture. If I said, oh, the ratio of girls to boys is 2:3, no, it's not. There are 3 girls to 2 boys. So order does matter. Make sure you write it as they tell you to write it. So in class, we will be separating. We will ask boys and girls to stand up, and we'll actually represent ratios here. So just pretending I made 3 boys get up one side of the room and 9 girls one side of the room. What's the ratio of boys to girls in this class? There are 3 boys to 9 girls. 3:9 and 3/9. Does this order matter? It does. If I had said 9:3, There are not 9 boys. I asked 3 boys to get up and 9 girls. So could I represent this in another way? Can I simplify this? I can divide both numbers by 3 and get 1 over 3. So that means for every 1 boy, there are 3 girls. So I would tell that 1 boy to find 3 girls, and that other boy to find 3 girls, and another boy to find 3 girls, and see if that is correct. How funny. What about if I had 3 boys, 9 girls again? The ratio of girls to total students class is what? So this is part to total. Girls, 9 girls, total 12 students. 9 colon 12 and 9, 12. Can I simplify this? I can divide both numbers by 3 and I get 3 over 4. But what does that mean, 3, 4? That means 3 girls, there are 4 students. For every 3 girls, there are 4 students. So I have a maid. So if in class, I would tell 3 girls, you need 4 students in your group. So they would find a boy to make a group of 4. Another 3 girls will make a group of 4 with another boy. Another 3 girls will make a group of 4 with another boy. So ratio. So ratio is comparing 2 quantities, its values. So you're comparing 2 things. It could be part to whole to part, or another part to part. So you can simplify it. It can be represented in 3 ways ratio. You can represent it with the word 2, colon, and fractional form, and you can simplify it. So this is ratio, comparing it to quantities.